Welcome to Mrs. Bibb's Algebra 1 Honors Class, Week 17. Please be sure to fill in your table of contents, complete your weekly warm-up, so sorry I hit that button, and you will need Student Journal page 114, maybe more, to complete this week's notes. The first thing you should do when you're trying to find a line of best fit is to make a scatter plot of the data if one has not been provided. Determine whether the data can be modeled by a line. Determine if the data has a linear relationship. That's another way to say that. Draw a line that appears to fit the data closely. Each of us could draw a line a little differently. Just depends on what you feel would fit the data closely. You should try to make sure, I'll highlight here because this is very important. You should try to make sure that you have approximately the same number of points above the line as below it. Here's an example that I want to talk about. Look at my practice scatter plot that's given. I've had students draw a line like this. That would be incorrect because you have this many lines below and this many points below and this many points above. So be very careful. You want that line that you draw to fit that data as closely as possible. So be very careful when you do that. If I were to draw a line to fit the data, and number one, it does not have to go through data points. You just need that line to go, approximately fit the data. So if I were going to draw a line, to me that line, of course it's a little messy, I apologize for that. That line fits that data closely, close enough. Look, I have 2 points above and approximately 2 points below. And then what you would do once you draw that line, you would select 2 points that are on the line. Not necessarily 2 data points, but 2 points that are on the line. Now mine is not drawn very well, but I'm going to select this point here, which appears to be 1322. And I'm going to select, let me draw this line in blue. Maybe I can do a little better job. I have to use a ruler when I do this myself. Now I'm a little above. Let me redo that. I think I'll select 0, 8. Then what we'll do is we'll write an equation of the line using 2 points. And let me re-emphasize, the points do not have to represent actual data pairs, but they must lie on the line of best fit, that blue line that I have drawn. So what I'm going to do is I'm going to use those 2 ordered pairs that I have selected. I'm going to find the slope first, y2 minus y1 divided by x2 minus x1. I believe that's negative 14 over negative 13. So my slope is going to be 14/13. I actually selected the y-intercept, but I want to go through this and find the y-intercept. We'll see if I get 8 as my y-intercept. So I would use point slope form. Y minus y1 equals m times x minus x1. Y minus 22 equals the slope times x minus 13. Yeah, I do believe I'll get 8, but I just wanted to show you what you would do. Y minus 22 equals 14/13 x, distributing. 14/13 times 13 would be, or negative 13 would be minus 14. Add 22 to both sides. So y would equal 14/13 x plus 8. Now it says, what is the weight of the baby when the baby is 4 months old? X is represented in months, so I'm going to substitute 4 in for x. So y equals 14/13 times 4 plus 8. Y equals 56/13 plus 8. Y equals, I'm going to find a decimal approximation for that. Since we're talking about weight, we do need decimals here. So I'm going to divide 56 by 13. I'm going to put 4.3. 4.3 plus 8. So y will equal 12.3. What is the weight of the baby when the baby is 4 months old? So 12.3 pounds. And this is my work for that. My next one says, what is the age of the baby when the baby weighs 17.2 pounds? So I'm going to substitute 17.2 in for y. I'm going to put 14/13. I don't know why that picture's doing that. I'm so sorry. I'm going to put 14/13 x plus 8. I'm going to subtract 8 from both sides. 17.2 minus 8 is 9.2. So 9.2 equals 14/13 x. I'm going to multiply by 13. That's 119. I'm so sorry that I'm squeezing this in here, and I can't even see that last question. I'm going to get 119.6. I'm going to go up here. Please forgive me. 119.6 equals 14x. I'm going to divide by 14. And we will use a calculator when we do these. X equals approximately 8.5 months. And you've got to make sure to have those units. X is measured in months and Y is measured in pounds. Now, I think I'm going to slide that up. I hope it'll be okay. What tends to happen to weight of the baby as the age increases? And what would you put for that? What is happening to the weight of the baby as age increases? And hopefully you thought, as age increases, weight. As age increases, and I couldn't hit that. I'm not sure how to move my little recording button out of the way. As age increases, weight. I'm going to write it over here. Weight increases. As age increases, weight increases. Okay, I'm sorry, that is a complete total mess. Okay, let's go on to the next page. As we look at these graphs, we want to decide if the data in the graph has a positive correlation, a negative correlation, or no correlation. So are these data points trending in a positive or a negative direction? And I would say positive for this one. How about these data points? They tend to be trending in a negative direction. And number 4, can you see any kind of line being drawn through those data points? No, so there's no correlation. I'm going to put none. And for number 5, what do you think? Is it positive, negative, or none? And hopefully you thought positive. Next example. Okay, we are going to, it says the table shows the depth y in centimeters of water filling a bathtub after X minutes. And I do believe that when I did this last year, we did a bigger graph, but let's just try. We'll go by 2s and see if that will work. We will say that my X, it tells me, is the time in minutes. And my Y is the depth. And that's measured in centimeters. And let's just plot those points. I'm going to go by 2s. 0, 2, 4, 6. 2, 2, 4, 6, 8. 4, 2, 4, 11. 2, 4, 6, 8. 10, 11. 6, 14. 2, 4, 6. 2, 4, 6, 8, 10, 12, 14. 8, 17. So 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 17. And I just cannot add those points 10, 20, and 12, 24. And I believe that's why we did this on a piece of graph paper last year. But we'll just go with what we have. And I'll make sure to provide graph paper when you need it. Drawing a line of best fit through that data, and I wish I had the other points, but I'll try to make it steep. And that line's not very, very good. I'll try again. Because if I go to 10, 2, 4, 6, 8, 10, 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's pretty close. And then 12, 24. That's pretty close. Okay, so I believe I am going to use this data point and this one. It does not have to be a data point, but I believe I am going to use that. I'm going to use 2, 8 and 2, 4, 6, 14. It says interpret the slope in the y-intercept. Oh, so I'm actually doing this up here. Write an equation that models the depth. Okay, so let's find the slope. 14 minus 8 divided by 6 minus 2. 14 minus 8 is 6. 6 minus 2 is 4. And that reduces to 3 over 2. Okay, and change in y. So this is depth in centimeters and time in minutes. I'm going to need that in just a moment. And let's find the equation. Y minus y1, so I'll use 8, equals m times x minus x1, which will be 2. Y minus 8 equals 3 over 2x minus 6 over 2. 3 over 2 times, 3 over 2 times 2 over 1 would be 6 over 2, which is 3. So I'm going to add 8 to both sides. So y equals 3 halves x plus 5. Okay, it says the table shows the depth of water filling a bathtub after X minutes. Okay, the slope. What does that slope stand for? This is what I interpret that slope as. The depth of the water, because that's my Y value, that's what it's measured in. The depth of the water increases 3 centimeters every 2 minutes. That's what the slope, my interpretation of the slope. And then the y-intercept, for me, the y-intercept says that that's how much water you started with. There was 5 centimeters, that's a crazy M, of water in the bathtub to start with. Okay, so there's example 6. Moving on to example 7. I believe we will do example 7 together in class. For my remote learners, we will go over example 7 together during our Google Meet. If you would like, you could go ahead and make your scatter plot, but we will definitely do this one together. For number 20, this is an example like in your homework. What it wants you to do is use a graphing calculator, and we're not going to use a graphing calculator. We're going to talk about the correlation coefficient here in just a moment. I'm not going to have you actually find correlation coefficients. You'll see why in just a minute. We're going to interpret the slope and y-intercept of the line of best fit, and then we're going to approximate using that equation that we find, both of these. So we are going to do this one together in class as well. Same with my remote learners. We will go over this during your Google Meet. And I want to show you what it involves to find that correlation coefficient by hand. That's why it's necessary to use a graphing calculator. But right now we're not going to use graphing calculators. We're just going to talk about what the correlation coefficient is. So I'd like for you to pause and read through each of these things, how to find the correlation coefficient. It says to calculate it, you have to calculate the mean of x, find the mean of y, then determine the standard deviation of x. And you can see this formula for standard deviation. That is the Greek letter here, Greek letter sigma, lowercase sigma. And it's just very complicated to do this. So you calculate the standard deviation of x, you calculate the standard deviation of y, and then you, see, it says for the correlation coefficient you have the means and standard deviation for your variables. So you can proceed to use the correlation coefficient formula. Remember, n represents the number of values you have. So this is the correlation formula. A calculator will find that correlation coefficient for you. And it says for this set of data that was in the original problem, the correlation coefficient is 0.988. This number tells you two things. So here's what a correlation coefficient is. First of all, it tells you that there's a positive correlation between the x data and y data. This means that as x values increase, you expect y values to increase. Also, since that correlation coefficient is close to 1, the x and y data are closely related. If it wasn't close to 1, they would not be closely related. And it says if you were to graph these points, you would see that they form a very good approximation of a straight line. It says correlation refers to the statistical relationship between two quantities. The correlation coefficient is a single number that you can calculate for any two sets of data points. It's a number that's always between -1 and +1, and again, it indicates how closely connected the data sets are. And I will not have you be finding the correlation coefficient. It's just something that we need to know what it is. And then here is your assignment for the week. My hope is to do number 17 together in class after we do those other two problems. And the goal this week is to have our week 7 assessment on Friday. I believe that's all for our notes this week. Yes, it is. Have a great day.